Yes, Ashik Shetty, can you hear me? Hello? Hello? Aditya Sam, can you hear me?
Yes, sir.
Yes. Ashik Shetty is not there. There is one more Ashik Shetty in the final year. Same name, Ashik Shetty. Where is this Ashik Shetty gone? Okay, we'll start. Huh? So we were discussing about work part transfer system. Work part transfer system means one more Ashik Shetty. Yeah. Ashiki nahi, Ashik, Ashik. Yes, I should say. Yeah, Aditya, can you see the screen? Aditya Sam.
Yes, sir.
Yeah. So we're discussing about the work part transfer system. So you have a transfer line. Transfer lines are generally used for mass production. Mm. So how the work is transferred from one machine or from one workstation to another workstation. So there are some mechanisms. Mm. Again, from examination point of view, it is just for a short note only. It can be asked. Not that difficult. Like now, this is assembly line of the automobiles. So in automobiles, there are basically two ways of transferring the product. One is called as the overhead conveyor. Overhead conveyor or also called as the J-type conveyors because there are J-type hangers used. J-type hangers are used. Hangers to which your bodies, car bodies are attached. So it moves overhead just at the height of the workers so that they can do the work comfortably. And other is ground level. So the bodies or the components moves on the ground. Mm. So automated production lines, where are the applications? You can find it in machining. So that's why it is called the machining transfer line. Machining means like suppose uh, you have to do machining on say cylinder head or a cylinder. Mm. So there are you know altogether five faces which are exposed because the sixth face, that is the bottom face, one cannot do anything because that is resting. Hmm. Because if you want to do any machining from the bottom face, then you have to remove that and you have to turn it upside down. So all the five faces operations can be done from the top, from the four faces, assuming a rectangular component. I am talking about a rectangular component. A cylinder head is a rectangular. So all the five faces can be machined in a transfer lines. And there can be many operations like on the top, you have operations like say drill, you have operations like rimming, then tapping. So usually a machining transfer lines consist of almost 10 to 20 stations, and it goes on continuously. And that's why it is called as the hardwire. Hardwire. Hardwire means fixed. It is not flexible. That is, suppose if the transfer line, machining transfer line is designed for machining a particular cylinder, then it will keep on doing that only. Then it can be used for spot welding lines, which is very popular. Then sheet metal stamping. Stamping means blanking operations or a punching operation on press machine. That is what is called as the stamping. हम लोग ठप्पा मारते हैं, So it is like a stamping. So that's why press tool operations like the blanking and punching are called as the stamping operation. Electroplating of metals, generally the transfer lines are not used much. Electronics assembly, yes, semiconductor assemblies, transfer lines are used. So where we use these production lines, so wherever the product demand is high, uh, mass production like furniture lines, lock assembly lines, lock, tala, uh, cupboard, mm, automobiles, like those. Stable product design where the flexibility is less because moment you say that it is hardware or dedicated, that means it is difficult to change. And nowadays we are talking about flexible manufacturing system, we are talking about agile manufacturing, we are talking about reconfigurable manufacturing system. So there uh, you have to design the production lines in such a way that it should be flexible enough to take care of other model. So generally, the automated production lines are used where the product demand is very high uh, and it runs continuously. That's why it is for the stable product design. The product life is more, at least several years. That is, once you set the line, you are sure that now 5 years I am going to make this product. There will not be any threat uh, to this product. Then we install that particular production line. Then if multiple operations, that is I just now I said on cylinder, five phases you have to do operations, top, face, then all the side four phases, except the bottom phase. What are the advantages that it has? This automated lines, advantages, disadvantages, design of the production is very well given in Groover. Groover is the name of the author. CAD CAM SIM by Groover. Then you have low product. These are the benefits: low product cost, then high production rates. That is, high production rate means mass productions. That is, cycle time will be less. Production lead time and working processes will be minimized. Obviously, the floor space is minimized. Then it can be unmanned. It can be unmanned, so the labor requirement is less. So, what are the different mechanisms? Different mechanisms. Uh, so, the questions what can be asked is what are the different transfer mechanisms? Explain one, or what are the different transfer lines, or what are the different production lines, that type of questions. So you have linear transfer systems and you have rotary indexing mechanism. Linear transfer system means what? The part is moving continuously in a straight line. Like just now I showed you that automobile conveyor or your cylinder machining line or your lock assembly line. And rotary indexing means the the lines are round round. So suppose if we have space constraints, all these lines now before you design these transfer lines, you have to uh, carefully study the layout. The layout study is very important. Layout study, like if you have a space, long space in a straight line, then you can go for linear transfer system. But if you have if you have constraint on the length, uh, but you can little bit stretch across width, then you can go for U type line or you can go for S type line, or you can go for rotary rotary lines. So depending upon your space, you are designing the lines, and of course there are advantages and disadvantages associated with the different lines. Because like suppose if you go for linear layout, linear transfer system, linear transfer system, then it becomes very difficult to reach from one station to the 20th station or maybe to the 30th station or maybe to the 40th station, because it's very long. That may not be the case in case of rotary indexing. Uh, Rotary indexing, if the worker has been asked, like worker from station number one has been asked to help to the worker, station number at station number say 10, uh, the travel length is less in case of rotary, or maybe in case of U also travel length will be less. In case of yes also the travel length will be less. So linear transfer system, this is important. That is continuous motion and synchronous motions. Continuous motion means the components are moving continuously. Synchronous motion means it is intermittent motion. All parts move simultaneously. Like you have say, let us take example of say 10 workstations. 10 workstations. So all the parts will move simultaneously. एक साथ आगे जाएंगे. So here it will wait. It will wait for the slowest operation to happen. So once that slowest operation has happened, then all the parts will be moved. That is what is called the synchronous. And continuous means what? Irrespective. huh? Whether the work is completed at a particular workstation or not, it will keep on moving. The conveyor speed is such that say, suppose conveyor speed is say 1 meters per minute. That is the velocity. Then it keeps on moving. So the peoples or the workers or the operators, they have to move along with the conveyor, and they have to carry the work. I said, workstation. Suppose if the work is continuously flowing, so he is working at one particular workstation, so he has to move because the conveyor is moving, so he has to move. Whereas in synchronous motion, the it is standstill. The conveyor is not moving. Once the work is completed at all the workstations, then the components will be moved. And asynchronous motion is intermittent motion. So part moves independently. Independently. So here it will not be considered whether hua, nahi hua at the slowest workstation. It will not be considered. So it just moves independently. So normally in automobile it is continuous motion. It is continuous. That is the parts are moving continuously along the line. The conveyor is moving continuously. So the workers they have to move along with the conveyor, along with the conveyor. So once they have completed, then you have to come. Then the workers they have to come back to the workstation because the component has already arrived at that workstation. Then you have rotary indexing mechanisms, and it can be done in two ways. But the Geneva mechanism is more popular. Geneva, which was studied in turret indexing mechanism. Turret लेथ में जो turret index होता है और in caption लेथ the turret which is index that is by Geneva mechanism. So as I said, in continuous transport, the work parts are moving continuously at a constant speed, and this speed can be increased or decreased depending upon the work content. Work content means at a particular workstation, what is the quantum or what is the amount of work to be done. That is what is called as the work content. So depending upon the product, the work content varies. Depending upon the product, the work content varies, and the designer, the engineer who designs the line, he studies the product first. He has all the information about the peoples. He has all the information about the layout, about the space, what is the space content, what are the peoples, what is the work content in the product. Like suppose if you talk about Bolero, then work content will be less as compared to your car, Volkswagen. So why? Because Volkswagen is top loaded. So their components are many components, whereas in Bolero the components may be less. So the number of workstations which are required for Bolero assembly line will be less as compared to Volkswagen का car. ऐसा. So workstation number of workstations can be 10 or it can be 40 or it can be 60 also. It depends how many workstations or what is the work content. And if you want to reduce the number of workstations, then definitely the work will be increased. Like suppose uh, a particular workstation is only doing the chassis mounting, or is only doing the gearbox mounting, or is only doing the fuel tank mounting. And so now chassis mounting, then gearbox mounting, fuel tank mounting. If you are doing independently, then there will be three workstations required. But now suppose if you want, if there is a space constraint and if you want to reduce the space, then you can design the transport line in such a way that at only workstation all these three things will be carried out. That is mounting of the chassis and mounting of the axles, gearbox, and fuel tank. Okay. But then that takes the time. That takes the time. So it depends upon the space. So lot many factors are involved in that. Okay. The bottling plant, not only that is again a typical example of continuous transfer line. Packaging is again an example of continuous transfer line. So intermittent or synchronous. Intermittent में और discontinuous motion में क्या? It will wait, you know, for the storage workstation to happen, and then the components will be moved. Here the conveyor on which the component is mounted is not moving continuously, not moving continuously. So that is what typical examples are: your machining operations, then your press working operation, hmm, your progressive dies, etc. Then, as I said, slowest workstation, that is slowest workstation is the bottleneck station, and you have to concentrate. Engineer has to concentrate on the slowest workstation because that is what we is going to decide the pace of the line. Pace of the line means speed of the line. Understand? Slowest workstation. Slowest workstation means where you know the type of work which is being carried out may be difficult, or maybe lengthy, or maybe some skilled, because all the work cannot be, may not take the same time. Mm. So accordingly you have to design it. Accordingly you have to provide the resources in terms of people, in terms of tools, and you have to see that the line is balanced. Line is balanced means there is not much difference uh, between the timings of workstation, different workstation. Like suppose if the line is of 20 workstation, and you have to see that every workstation, the time required to carry the work is, for example, 1 minute. If it is 1 minute, if the cycle time is 1 minute, then you have to see that every workstation near about takes 1 minute. Hmm. Like say if the two-wheeler car cycle time is, I think it is some 45 seconds something, Bajaj car. Means what? Every 45 seconds one two-wheeler is rolled out. उनका जो assembly line में है, every 45 seconds,
Sir, now
every
it's
every
28 seconds.
hello, yeah.
Now it's 28 seconds, sir.
Now how much it is? 28.
28 seconds.
Yeah, 28 seconds. Okay, okay. Bajaj car you are talking about.
Yes, sir.
Yeah. So thank you for updating. So every 28 seconds it but do you know about this thing about Maruti? I think Maruti car is 55 maybe.
No, sir, I don't know.
Maruti car,
I knew about
you don't
Bajaj
know?
because it's in Aurangabad, so there are many industries
Okay.
supporting it.
Okay, Bajaj. So see, that means see every 28 seconds you are, it is rolling out. Every 28 seconds it is rolling out. So you have to see any particular workstation. Suppose if it is taking say 35 seconds, and then the manager or engineer has to see that how to reduce it from 35 seconds to 28 seconds. Otherwise, your cycle time will become 35 seconds instead of 28 seconds. So thank you. Means almost in 1 minute, the two motorcycles, you are getting an output of two motorcycles in 1 minute. That means in 1 hour it is 120, more than 120. Please, 120. And if you are talking about 8 hours production, so it will it will be almost, in a shift it will be almost 1,000. And in this mass production, it is seen that the lines are working continuously. That means there is kind of a people, they are called as the floating people, floating operators. Floating operators means what? If some worker or some operator is going for some, refreshment, washroom बोलो or canteen बोलो or for breakfast बोलो, then there are floating operators who takes his place, and he sees that, the line is continuously running uh, because of the volume, because of the cost. The manufacturer cannot afford to keep the line idle, because if one workstation is idle, that means the entire production is stopped. You say that is the role of the floating worker. Hmm. Floating worker बोलो या floating operators. This is supposed to be high skill, and even sometimes some companies they have staggered timing, lunch time ka. Not everybody goes at 11 o'clock, so it is 11 to 11:30, 11:30 to 12, 12 to 12:30, 12:30 to 1, like that. 11 to 2 hours may it is spread, so that it is seen that, the line is not stopped. So transfer can take place, palletized transfer line and free transfer lines. So this is how your automated production line is. Like say your the part is moving here, and these are your station one, station two, like that. This is a brake line, like that. There are many stations. So this is station N. This is obviously N minus one. Like suppose if there are 40 stations, then 40 minus one, so that is 39, then 38, and these are the completed part. This is So if this is mounted on a conveyor, so conveyor is moving continuously, and then products or the components are also moving continuously. So suppose if the worker is working at this station number two, imagine now, station number two. I'll show the videos later on. uh, hmm. If the worker is or a team of peoples, there can be one worker, there can be four workers also. Double sided. See, double sided means two workers from this side and two workers from exactly opposite side. So four workers. It can be three. So like suppose if it is a tire mounting station, so two here and two exactly opposite. So four peoples. So now this conveyor is moving. Of course the speed is slow. The conveyor is moving. Fine. So the peoples also has to move, along with the conveyor and complete the part. Okay. So by the time now this station has moved, uh, it has gone here. The peoples are also moving. The team of the workers they are moving. Okay, they complete. Okay, and then again come back to their original place, because by that time this component has come. Okay, so like that is, it works. And this is what is your, Geneva, that is rotary indexing. Of course, here there is a limitation that number of workstations cannot be more, cannot be work, cannot be more. So normally we have around, maximum what we can have is 20, not more than that. So generally this type of, rotary um, layouts are used for components like lock, uh, tala, 5 lever, 6 lever, because the work content is not much. Maybe 5 to 6 workstations are enough, for even for the cupboard also. Almost 15 stations are enough. So here the advantage is the space. The space. If you have a little space, then you can go for the rotary. Another advantage is like suppose if one worker is idle, like say your workstation one. Suppose this is say 10 workstation. So this is workstation one, 2, 3, 4, 5. So if this fellow, suppose he takes suppose 30 seconds, and if this fellow is taking say 1.5 minutes, so we can ask, no, manager can ask that once you complete this your work, then you go and help him. So that 1.5 minute can be brought down to 1 minute. So like that. And then again go back to your workstation because the components are coming. So since this is possible in rotary only because the moments are less. Because the moments are less. There can be another lines like say L-shaped layout. This is now your L-shaped layout. You can have. U-shaped layout. So again, U-shaped layout my advantage is that the worker from this station can be, you know, asked to help this, because the travel length is not much. Travel length is not much. Had it been a straight line, then it is difficult, because by uh, suppose if he is taking 30 seconds and another person who is at the 10th workstation is taking 1 minute, so it is very difficult for this fellow to reach there and again to come back. उसमें ही उसका time चला जाएगा ऐसे. So in such cases, U type lines or rotary lines or S type lines are very important. These are your machining lines. Machine line. These are two machining transfer lines. This is one line and this is another line. Okay. So these are your pallets, pallet storage. Okay. So the components are stored here on the pallets, and then it is moved uh, to another line. So again, it is all happening, automatically. All, so the unloading of the component on this pallet, and then this pallet moves here, then it loads here, okay, and then again it comes back here. This is what a typical layout of your rotary indexing machine. So here the part is in, this is moving continuously. So one workstation, second, third, fourth, fifth, sixth, and then completed part is out. You see. So the mechanism is here, most popular mechanism is rotary indexing के लिए, that is Geneva, Geneva indexing mechanism. Well-driven linear systems. See, this is all, all this is, incorporated below the ground. Means like say this is now where are your components? Your components are above the ground. Okay, so all these conveyor systems are below the ground. मतलब ground के नीचे ऐसा बड़ा खड्डा रहेगा. We call it as a pit. Understand? और वो pit में आपका ये सब रहेगा. All this, conveying parts or conveyor parts. So generally the now this is all your components. So this is what is your floor level where the conveyor is, and all these wheels or this pillow or these pulleys will be below the ground level, below the ground level. So it is seen that maintenance is very religiously followed here in these mass production lines, because if something goes wrong only because of the maintenance, then the production is suffered, and the production is suffered, as well as um, it takes time also, to repair. So every week, on the weekend or on the weekly off, the entire plant is uh, the preventive maintenance is carried out in entire plant. Not only this, there is preventive maintenance every 15 days, every 1 month, and there is something called as the shutdown, that is annual shutdown. So compulsorily all these mass production people, they take shutdown once in a year, maybe for 6 to 7 days, and usually that shutdown is observed during the festive season, like where there are long leaves, maybe like year ending, it is Christmas vacations or New Year, because the maintenance they plan in such a way that they at least take 7 days, so that they can do it comfortably. Otherwise, say info maintenance staff, they have so much of pressures from the production people. अरे चालू करो कैसा भी करो चालू करो, because production people, production engineers, production managers, they always have targets in their mind. Targets, इतना टारगेट है, इतना कंप्लीट ही करना है आज, ऐसा रहता है उनका. तो दे आर आफ्टर मेंटेन, कैसा भी हो, चलो चल रहा है ना, क्वालिटी बाद में देखेंगे, चल रहा है ना, चलो चलाओ, दबाओ, दबा के चलाओ, दबा के चलाओ, and in order to meet the target they will increase the speeds and feeds. Yes, sir. So maintenance staff is under tremendous, pressure. So in annual shutdown, say जो भी है 4 or 5 days का या 1 week का, so they can at least do it fully because the staff, the entire staff, production staff, they are on leave. Maybe Diwali or ऐसा. So maintenance is very important in the mass production. Belt conveyor is used when the distance is very long. As I said that these uh, conveyors, number of workstations are many, like say 20, 30, 40. So usually you cannot go for the gear transmission. So you have to go for either for a belt or for a chain. Then there is another mechanism which is called as the walking beam transfer system. Walking beam transfer system. So that is nothing but something called as a rack and pinion type mechanism. So this is used when the number of stations are limited, maybe 5 to 6. Walking beam transformation. Usually the belt conveyors and the chain conveyors are common. What I showed here, these are the common. And instead of belt, you can use chain also in order to avoid the slippage because the belt will give the slip. This is what is your Geneva mechanism, which is used for your road. So you have a small driver. So this is what is your driver and this is your driven. So it will keep on, indexing one after other. So you have this locking pin so that when it is to be indexed, this get detached. Then it is indexed. Then again this pin get detached means it will come out. So this is rotated and this is self-explanatory. This gets rotated and then this slot will come over here and moment this slot comes, this pin will go and engage in this slot. So it gets locked. Again, after the work is over, this is detached, it moves out and it will be indexed. And again, when this slot comes, this pin slips inside. This is the cam mechanism to drive the indexing table. So again, this is a cam and follower. So cam and follower, this is a groove and this is rotated with the help of the motor. So the follower of index plate is moving in this groove. So that when this rotates, I hope you can imagine and understand. So once this rotates, you don't have to draw this three-dimensional picture. So once this rotates, the follower which is moving in this groove, it rotates and the table is rotated. And number of workstations are on this index plate. Then there is something called as the buffer. The buffer, because why no? As I have been always saying that balancing, line balancing is a very uh, critical issue in assembly lines, in design of assembly lines, line balancing. It is very important that every workstation has nearly the same time. Otherwise, one worker is overloaded and other worker is enjoying. So it is very necessary that the component moves, the workpiece moves with the correct calculated speed. mm, And in case, if it is not possible to avoid, that is suppose it may happen that in one workstation the time is very less. Like say the cycle time, as Shrenik said, that it is say 28 seconds. But suppose in particular workstation the cycle time is say 14 seconds. So half the time he is idle. So he is keeping on, you know, producing the products every 14 seconds. Then we should have provision to store, because the cycle time is 28 seconds. So if he is producing every 28 seconds, then the components will move. But now he is producing the double the components than required. So you should have a provision to store these work pieces in between the workstations. In between the workstations, so there has to be a space where the components generally, and that is what the limitation. Because see, if it is two-wheeler, the component size is less, so there it is possible. Uh, But if it is, four-wheeler, then in between two workstation, it is very difficult to, keep storage space. At the most, you can store one body, one car body. But if the previous workstation is producing number of, bodies, so how to store, 10 bodies? How to store 20 bodies? So that is the limitations. But bottling plants बोलो या packaging stations बोलो, there you can manage, or even your cigarettes, Godfrey Phillips cigarette ka lines, that is packaging lines, how the cigarettes are packed in the pocket. So there you can have, a buffer space. So if particular workstation is producing, you know components at faster rates, and if the next station is not capable of, taking all those products, then there is a buffer place where the components are kept or can be stored. So this is again a technique which is followed in assembly lines. And that fastest workstation, he completes his work maybe in half the shift continuously, then he is asked to go to other department to work, to do some other work, not other department, but do some other work. He is asked to do some other work. This is how you can do the man man. See, this is what I was talking about, the storage buffer place. So here, hmm, like say now this is fastest workstation. So he is producing the component. This is little bit slow. So he is not able to finish all the components which have been produced by this operator. So all the components will be, will be stored here. And then once he is completed the target of, say the target is now in case of motorcycle 1,000 car, hmm, then he will be asked to, do some other work. But in case of heavy components, I mean heavy component means the larger size component, this is not possible to provide, buffer space. But this is possible only in the components like, bottling plants, or component like, cigarettes packing lines. There it is possible. If the component size is very small, or your electronics, semiconductor, assembly lines, there it is possible. So what are the functions here? You should have a good sequence control. Then safety is most important. Safety, especially in other countries, in European countries, safety is the most important. Because why no? See, here the line is moving continuously. The peoples are moving along with the line. So body parts, or maybe clothes, loose clothes, if somebody is wearing, or if somebody has say long hairs, so that should not get trapped in the moving parts. So that care has to be taken care of. Mm. Even the loose belts, wristwatches, the chain the operators are wearing, so that has to be taken care of. You know. So that's why, if you see these assembly lines of the foreign companies like say Mercedes or Volkswagen, before the operators they start their work, they have to remove everything. पूरा निकालने का, remove everything means what? मतलब तुम्हारा बेल्ट निकालो, तुम्हारा चेन निकालो, इवन तुम्हारा रिस्ट वॉच भी निकालो, रिस्ट वॉच, because they are so particular. uh, then you have to tie the hairs, so you have to have a proper cap, proper cap. Then you have to wear the gloves, proper gloves. Not only safety, but they are very particular about the damages also. Like it has happened that belt ki wajah se or wristwatch ki wajah se there are scratches produced on the component. Like if you see Volkswagen, I'll show the videos, Volkswagen ka, or you see the assembly line finished product, it is so mirror finish. So even if somebody is wearing a belt or a wristwatch and he is doing the work, a small scratch can damage the entire product. Pura body scrap कर सकते हैं नीचे. So that's why they are not allowed. Have you even to chain also? So they have to remove all the part and then only they have to go to the workplace. Ours is now cement concrete. Most of the our Indian plants, the flooring is cement concrete. But some plants like Volkswagen, they have totally wooden flooring. The concept of wooden flooring. Like now in the construction, residential flats also, we use wooden tiles. So there, the entire the plant assembly line is wooden flooring, flame proof, waterproof. Because ergonomically and fatigue wise, wooden floorings are better. Wooden floorings are better. So this is very important. That is, safety is very important and quality is very important. So that's why they are not allowed to wear the wristwatches. Even for the visitor also, if you are visiting Volkswagen, you can visit anytime. So they have like even Parle ka chocolate ka assembly lines. Parle G, Ville Parle. Now it is not there. Uh, they have chocolate assembly lines. Then they have biscuit assembly lines. So they have a separate track for the visitors. Anybody can visit. You can arrange your society ka visits. You can arrange your school visits. For visits for the kids. Because that is their marketing strategy. So they will, if the peoples are more, then they will make the arrangement to pick up and to drop also. So they will pick you up from your society. They will send a vehicle, and there is a separate track for the visitors. You have to go through the track also. They will give you first. They will show the presentation, what is their product, etc. They will give you a lot of biscuits to eat, chocolates to eat. So this is nothing but a marketing strategy of Parle G. So Volkswagen also, you can go to their website and there is option called as the industry visit. So you can book your visit. You can book your visit, and so many visitors are there. No, so sometimes it takes 2 weeks to get a call for the visit. Then the this now design, system design. This is again very important. Like what is the approach, that building block approach. So every module, module wise approach. Then you have to link all the workstations. Then there are peoples who are specialized in building these transfer lines. So you can offload this work to those peoples. You can offload these works to these peoples. But beforehand you should have all the statistics. That is, what is the work content, what is the size, what are the machineries that you are going to have at each and every workstations, whether it is semi-automatic or fully automatic, mm, whether you are going to use pneumatic runner or whether you use spanners only and you are going to do manually. Because if you are going to use pneumatic runners, uh, then you should have a provision of airlines. If you are using some kind of a hydraulic cylinders for lifting the tires, hmm, for lifting the tires and for placing the tires, suppose if you are using hydraulic cylinders, then you should have provision for mounting the hydraulic cylinders. So in tire mounting station, at the tire loading station, you near that point at the axle, you have to have a pit. आपको pit खोदना पड़ेगा. There you'll have to mount the hydraulic cylinders. Hydraulic cylinder के ऊपर piston rod के ऊपर you'll have to mount a plate. On that plate, you can place a tire, and then that will be lifted and it will be aligned and that will be mounted on the axle. So all this, called as the design consideration. And in this, you have to see that as far as possible, you use all standard units, standard units, standard motors, standard belts, standard chains, standard gear, standard gearboxes, standard, columns. So that saves your time. That saves your time for setting up the line. As well as it becomes economical also. It becomes very economical also if you are using standard units. Again, the same thing here, that rotary transfer. This is the plan view, same, that is which I have already shown. That is, you have a part in and then you have a part out here. Same thing, the top view. mm, Then how to analyze transfer lines? You have mm, line balancing. That is, you have to see that you have to divide the lines in number of workstations. Actually, the number of workstations has to be more, so that your cycle time can be reduced. But then, depending upon the layout and depending upon the space, you can take this decision. Then line balancing is very important. So there is something called as the balancing efficiency. These are called as the KPI, that is key performance indicators. There is something called as the balancing efficiency. There is something called as the resource efficiency. So some models, mathematical models are there. There is something called as the balance delay. So all these, mathematical models will give you the efficiency of the line. So in line balancing, we divide the work head. Work head matlab workstation. Hmm. Then processing technology. Hmm. As far as possible, you have to have a compromise or a trade-off between automation and that is fully automation or fully automatic and semi-automatic. It depends, like suppose if there is a money, uh, there is a budget. Uh, uh, so if you want, see, ऐसा नहीं है कि the people they don't have money, they have money to pump in, but the problem is, suppose if you automate the entire line, so the investment will be very high. Then everybody will think of, or everybody will always, the investor will always calculate the return on investment. How much return he is going to get. If he is going to get more than say 10%, maybe around 12%, 15%, then only he can invest. Because if he simply keeps in FDs or in mutual funds, he is going to get 8%. So why to have headache? So if the return on investment is around say 12%, 15%, then only he will think of. I say. So that is one thing. And second thing is, if you automate the line, then definitely that cost will be imposed on the product. I hope you understood. Your product cost will increase if you automate. Like suppose you can have a robotic line, entirely robotic line for Bolero. But then Bolero, what you are getting? I don't know exact figure, but let us say, suppose if it is, if you are getting it for say 4.5 lakhs or 5 lakhs, if I robotized, one robot is costing around say 50 lakhs, building ka bolo, yeah, tire mounting ka, or even sometimes body mounting, that is called as the marriage. That is chassis and body. That is on the chassis, you are mounting a body. You are mounting a body, so that also is fully automated. But then robo which is used for that body mounting, that cost around 50 lakhs, or entire your steering gear. that can be automated. And Volkswagen, they have all these kind of facilities, so that's why their product cost is more. So Bolero, suppose if you robotize everything, then the cost of the Bolero will be high. So 5 lakhs ka, it may happen that it becomes 7 lakhs, but then that has to be afford by the customers. Normally now Boleros are been taken by all these um, people like newspapers wala, ya bhaji wala, vegetable person or milkman. Those people, they use this for transportation purpose. So they should be able to. And then of course, so that's why if you try to you have to have a trade-off. You try to automate, the cost is going to increase, and then reliability. Hmm. So as far as possible, your system should be reliable. So that's why that is what is called as the reliability. So reliability of the entire line. So that will come from the reliability of the individual component. Individual component से आएगा reliability. So if the reliability of individual component is high, then only your system will be reliable. Alright. So if you have any doubts, we'll stop here. I don't want to take new modules. If you have doubt, you can ask. Otherwise, you can leave it. Hmm. Raj Jain is not. No, he was not there. I think.
Sir, Raj Jain was there, but he left the meeting.
Raj, Acha. And Raj Bhosle was not there. He
Sir,
is
that
absent
I
for
don't
quite
know.
a long time. I don't. Huh?
Sir, Raj Bhosle, I don't know. Matlab, I don't know whether he was there or not.
You. I think he was not there. Yes, thank you, Aditya.
Thank you, sir.